Hello, welcome back. In this segment we're going to exercise using the looping and repetition structures that we've had introduced in the previous segments. So as you would expect, the problems that we solve get a little bit more complex each time we introduce some new control structures or some new operators to the language. There are three specifications in this segment, and what I would encourage you to do is when a specification pops up, go to your development environment and see if you can solve the specification, or think a lot at least about how you would approach the solution to this, and then watch as I solve it in the development environment and see if your way of doing it matched the way I did it. It's a more valuable learning exercise if you try to solve these problems without help and then get help afterwards. So some balance between being too frustrated because you can't see the solution and not trying it at all. Okay, here we go with the first spec then. Let's have a look at this spec now. Ask the user for an integer. Calculate and output all of the factors of that number. So here's what we want the program to output. Suppose the user entered 12. The factors of 12 are 1, 2, 3, 4, 6, and 12. These are the numbers that divide evenly into the number 12. The factors of 8 are 1, 2, 4, 8. So we have a problem now that requires us to calculate the factors of an integer. Before we start writing code, we can think about what the parts are. Well, ask the user for an integer and retrieve that or input that number from the user is not too hard. And then the interesting part of this will be how will we exercise repetition and selection to calculate the factors of the number. And so let's start out by thinking about whether we need a loop or not. So suppose the user enters the number 1248. There isn't any way we're going to write lines of code to handle each individual number, so we're going to write a loop that will calculate the factors. So if we think about the number 12, are there any factors less than 1, and are there any factors greater than 12? And there aren't. So it seems that we have a start place and a stop place for a loop. It's a good idea to work progressively, to take these problems apart and do the parts that you know how to do, and then when it's a fill-in-the-blank problem, the rest of the problem sometimes is a little bit easier to see. So let's start with that. Let's say we're going to make a loop that outputs the numbers, all of the numbers from 1 through n, and then we can decide which of those numbers we actually want to output in the final solution. Okay, I made a new project in here for the factors problem. I'm going to put the spec here, ask the user for an integer, and output the factors of that number. The spec is easier than the solution, as you might expect, a one-line spec. Let's include the usual ones, the standard io.h and the standard library.h. Working progressively, make a program that works, and only work with a program that works all the time. Here's the smallest possible program, system pause. Let's make sure that that works. So the compilation has worked, and it should run and do nothing except say press any key. I can find the any key. So let's see. We were asked to input a number from the user, so let's declare a variable, a number, and now let's prompt the user for that number. Enter an integer, and let's scan in that number. Scanf. We're using %i for integers. Ampersand number. Okay, now we want to have a loop that will go from 1 to number, and we will want to output each of them. Let's output all of the values from 1 to number, and then we'll have a fill-in-the-blank problem where we can decide which of those are factors. So suppose the user entered 12, we want to output the values from 1 to 12. Well, we need a control variable, or a variable to use as a counter in the loop, and each of these values from 1 to number is a potential factor of number. So I'm going to call it factor and see if that works out. Let's make a for loop. This is a counter-controlled loop, even though we don't know how many times it's going to go. We kind of do. We know that it's going to go from 1 to number. So this is the general form of a for loop. It has 2 semicolons here. Expression 1 is initializer, so let's say factor gets 1. That's the smallest possible value. And how do you get there? We're going to go in steps of 1, factor plus plus. And we will continue so long as factor is less than or equal to number. And inside the loop we will output each of the numbers corresponding to the variable factor, each of the numbers that are in the variable factor. Let's put a space there. Okay, let's see if that compiles and runs and does hopefully print out the numbers from 1 to n. And let's use the number 12. And it did output the numbers 1 through 12. Probably a carriage return at the end would have been useful, so it doesn't get messed up with the press any key to continue. There, not too hard, just makes it a little neater in the output. Our spec also said we would output a message, the factors of this number, and then a colon and a carriage return. How's that? A little bit better. How did that 7 get there? F7 is what I meant to do. And that succeeded. Now let's run and see if this seems to be working. If we put 12, the factors of 12 are 1 through 12. And of course this is not the correct answer. But now what we want to do is to decide which of these we should actually output. So you might be hearing me say that we need to have a a selection statement around this. So we're going to output that number if something is true. So if what is true, we need to have a relationship between factor and number and examine that relationship and see if it's time to print out the value of factor or not. Okay, how would we determine if a number is evenly divisible into another number? We can use the modulus operator. Let's try that. Instead of putting in the variables, I'm going to put in just some numbers. Suppose I wrote if 12 modulus 6 is equal to 0. 12 modulus 6 is equal to 0. Is that true or false? Excuse me, that's true. 6 goes into 12 twice with no remainder. So now what we want to do is to replace these numbers with our variables, and let's try it. We've only got two. Let's say if number modulus factor is equal to 0. So in the test case we've been using, number has been 12. 12 modulus 1 is equal to 0, 12 modulus 2 is equal to 0, 12 modulus 3 is equal to 0, and so on. It seems like this might work. Let's run it and see what it does. F7 to compile. And F5 will run it. Enter an integer. Let's try 12. The factors of 12 are 1, 2, 3, 4, 6, 12. That seems to work. Let's try another one. F5. Enter an integer 7. The factors of 7 are 1 and 7. (1,248). There are the factors of 1,248. There's quite a lot of them. Certainly more than I would want to be calculating with a pencil. Okay, let's clean this up just a little bit. The spacing is mostly a convention. Typically people would put a blank line before a loop structure and before a selection structure. These are not hard, fast rules, but if everyone does it the same way, then it starts to get easier to read other people's code. Okay, let's go and have a look at the next spec. It has to do with prime numbers. This spec is very closely related to the previous one. In the previous example, we were finding out what the factors of a number are, and in this one we're going to find out if a number is a prime number. And if you remember, a prime number is a number that is divisible only by 1 and itself. So it's considered that 2 is the first prime number and the only even prime number, because all other even numbers are divisible by 2. So 13 is a prime number, but 15 is not, because 15 is divisible by 3 and 5, as well as 1 and 15. 7 is a prime number, we saw that in the previous one, and 27 is not a prime number, 3 9s are 27. So here's what I would like you to do. Go to the code that we just developed using to find the factors of a number and modify it so that it will determine if a number is prime. So we're going to ask the user for an integer, and we're going to calculate if it's prime and output only one time whether it's a prime number or not. There are lots of different ways of solving this. The fact that we're starting with a program that finds the factors of a number kind of encourages you to do it in one particular way, but it doesn't make any difference. It's a good idea if you pause this now and go ahead and solve this problem on your own. It might take an hour, it might take 10 minutes. You have to think of the time that you spend now developing these problem-solving skills as an investment, because when the problems get more complicated, the skills that you've developed at this point will decide how long the problems will take when you come to more complicated ones later in this course and in your future programming classes. Okay, here's what I've done so far. I created a new project called Prime. Prime Numbers is the project, and I added a file called prime.c, and I just pasted in the program that calculates the factors of the numbers. So this will be our starting point. I changed the spec here, ask the user for an integer, and determine if that number is prime. So in this case, what do we want to do that's different from what we did before? And, well, what is a prime number? It is a number that has factors of 1 and the number itself. So we might, in this case, choose to, instead of outputting all of the factors, which is what we did here, when we find a factor, we might want to count it. So let's make a counter variable called countFactors, and we'll start that at 0. And every time we find a factor, instead of outputting it, we will say countFactors plus plus. Now let's output how many factors we counted. Printf, there are %i factors. In %i. Might be a little more informative. So we want count factors and number. See if that will compile. Enter an integer. 12. Well, the factors of 12 are, doesn't make sense anymore. There are 6 factors in 12. Is that right? 1, 2, 3, 4, 6, 12. You couldn't see me, but I was counting on my fingers. Let's try it again. Let's try it with 7. There are 2 factors in 7. Okay, so this message doesn't make sense anymore. The factors of I are, and this message at the bottom isn't really what we want. We don't want to output the number of factors. We want to output if the number is prime or not. We have the information that we need. If there are 2 factors in the number, then that number is prime. So we're going to write if count factors is equal to 2, then we can output %i is a prime number. X/n else %i is not, scream that, not a prime number. And we left out, I get very collective when I make a mistake, I left out the variable there, number, and number. This is a bug that I type all the time. I seem to leave out the variable that corresponds to the formatting string, and it will print out a bunch of garbage, and that's kind of alarming. You have to go looking for why did that number happen, and it wasn't really a problem in the calculations at all, only a problem in the output statement. You might also notice that in this if-else statement I didn't use any braces. I usually use braces even when they're not required. So in this if statement up here, these braces are not required, and in fact in this for loop the braces are not required. This is my personal preference. When you have to add more braces than you have lines of code, then I tend to just stop using them. But if there were more than one line here in the true part or the false part, the braces would be required. So that's something that we looked at quite early on, and maybe we should revisit that once in a while. And the convention is a blank line before an if statement, but not after, and a blank line before the for loop, but not after. Okay, let's try this. F7 to compile. That succeeded. F5, enter an integer. Let's try 12. It's not a prime number. And let's try 7. 7 is a prime number. Now we're outputting a message that we weren't asked for. There are blank factors in blank. It usually wouldn't matter that you leave something in that isn't in the spec. If you don't include something that is in the spec, then you're in more trouble. But you might choose to, because the spec didn't ask for that, leave that out and just do what the spec said, slightly more precisely implementing the specification. They really did ask for one output message, whether the number is prime or not. So there's the solution for, or a solution for determining if a number is prime. There are many more. Probably mathematicians are saying there are better ways of calculating a prime number. I really don't care. What we're interested in here is we have a repetition construct with a selection construct inside. So that's the level of complexity that we're working on. It's the next level of complexity after just having a repetition. So this problem requires an if statement inside of a loop of some kind. Okay, let's have a look at the next spec. Okay, here is your last spec in this segment. This one is a little more code, but in some ways it's an easier problem. So it's called Choose Your Dessert, and we're going to present a menu to the user, allowing them to choose what desserts they want, and we'll include a price for each item on the menu and at least 3 choices that are numbered. So we'll number our dessert options, and there will be an option on the menu to exit the program, so you've ordered enough desserts. After each time the user selects something, we will output the price so far, the total price so far. And when the user chooses to exit the program, we'll present the total price of the order. Well, that has a lot of stuff in it, and it's easier to think about this if I just show you what I expect the program to do. So here's what we can use as a test case. So the program will output choose one of these desserts, 1, 2, 3, 4. The first 3 desserts have a price by them. The first three choices have a price by them, and choice 4 is to exit the program. So the user chooses 2, and the program responds, so far your order is $2, and then choose one of these desserts. We present the menu again. And the user chooses 1. So far your order is $3.50. And then choose one of these desserts. And we keep presenting the menu for as long as the user does not choose number 4, which is the exit. And then at the end we will present a summary message of the order, that the order in this case is $3.50. Okay, we will probably have to flip back and forth to this spec as we're developing the code so that we can remind ourselves what all of the things are that we have to do. So let's go to the development environment and make a new project called desserts or something like that. Okay, we're going to work on this desert. I knew I would do that. This dessert problem. This is I'm going to flip back and forth to the test case, and this is a good way of keeping track of what we were supposed to be doing. So we're going to ask the user to pick one of the desserts, and it looks like we're going to do that over and over. So if you do something repeatedly, it's going to be inside of a loop. So we know that we have a loop, and we know that it's going to stop at some point. And let's see, it's going to stop when the user enters a 4. So we have a stop condition then, that we want the user to pick something off of the menu, which is the exit case. So let's start developing this as simple as possible and get something that works, that outputs a menu and allows the user to pick something. So you don't have to begin at the beginning, you can kind of work from the middle. And I know that we're going to have a while loop of some kind, because I don't know, it's not a counter loop, because I don't know how many times the user is going to pick something off of the menu. They're going to pick something while they haven't picked the final case, or the exit case, sorry. So let's output a menu. So here's a printf statement. I have no memory. Choose one of these desserts, not deserts. Choose one of these desserts, \n, and close quotes there. Now we're going to start outputting the desserts. One is ice cream, and ice cream apparently costs $1.50. Well, why don't we instead put %.2 LF \n, and then we can put ice cream price there. So if the price of ice cream changes, we don't have to go through all of the code and fix this. I'm going to close that, give us a little bit more room horizontally there. So I'm going to declare a variable double ice cream price, and I'm going to put in it 1.5, which is a double value, and it will translate into $1.50. So you're getting the idea here that we're going to output one printf statement for each thing on the menu, including one for the exit condition, and then we'll input what the user chooses. Let's declare a variable for the user's choice, and then after the menu is output, scan in. This is an int %i %choice. Okay, so the user makes a choice, and then we will do something with it. So far so good. When do we want to exit this loop? How about while choice is not equal to 4? 4 is the exit case. Let's initialize choice to 0. How many times do we want to do this loop? We're going to ask the user to, from the menu, output the menu, get the choice, take action based on choice. We want to do this at least one time. We want to present the menu, and if their choice is to exit the very first time, then they will have ordered nothing, but still that's a reasonable choice. So instead of making this a while loop, why don't we make it a do while loop? So I'm going to take the while down here, and I'm going to write do up here. So do, output the menu, get the choice of the user, and then check for the exit condition. I wonder if this compiles so far. Let's see. Okay, we have one warning. Right now they want us to be using this a newer version of scanf, but we can ignore that, and we have a program that seems to do something. So this loop should keep going for as long as the user doesn't enter a 4. The only reasonable choice so far is to enter a 1. Let's add the 4, the exit option, onto the menu, and let's compile and run this just to see that we are kind of on the right track. There's going to be a great deal more of trial and error as you solve these problems. Choose one of these desserts. If we pick 1, we'll get the menu again. In fact, if we pick anything except 4, we should get the menu over and over. And it doesn't seem to have exited, and I'm not sure why. Oh, I had a breakpoint in there. Sorry about that. So we did exit from this loop when the user entered the value 4, and we don't need that breakpoint for now. Okay, let's think about filling in the rest of the menu, and then we'll worry about the rest of the spec, which is, what else do we have to do? We have to So far your order is $2, so far your order is $3.50, so it looks like we need an accumulator variable to keep track of the value of the cost of the order. Let's work on our menu a little bit more. So if the user picks 2, it's going to be apple pie. %.2 LF \n, and now price for apple pie. Now what we had done so far is we are declaring variables with the prices in them, and apple pie is $2.0, and I'm going to introduce something new here that would allow us to define a constant. So this ice cream price will not change throughout the whole execution of the program. Throughout this whole program, ice cream price is going to be $1.50. Well, when we know that, we have the option in C of defining a constant using something called pound define. And these are not variables. To distinguish them from variables, we're going to use all uppercase and the underscore as readability character. Okay, so we're going to pound define apple pie price and I think we had one more, pound define cheesecake. How much was cheesecake? $3.50. 3.5. Okay. Now that means we won't need these anymore. They're not variables. They're going to be constants. And ice cream price can go here. And apple pie price can go here. These are not variables. Let me try to explain what happens. It's really not complicated. When before the C program is compiled, there is a substitution of 1 to 1. So every time this symbol appears in the program, this is substituted for it. So this is exactly the same as if we put 1.5 here, which is a double value, and it can correspond to this, and it would be output correctly. Every occurrence of apple pie price will be substituted for 2.0. So it's a 1-to-1 substitution, and it happens before the compilation starts. Here's what you'll do wrong, maybe. Try not to do this. You can't put an assignment operator there, and you can't put a semicolon there. This is not an executable C statement. It's a precompiler directive asking you to, well, you're asking the compiler to do this 1-to-1 substitution before the program starts. Now let's add in the other case for the third menu item, cheesecake. $2LF \n, and use the defined constant. And let's see what we have so far. We have a loop that will output the menu and ask the user for the choice, and then based on that choice they will either continue looping and choose something else, or the loop will exit. So let's compile this, see if we've made any typing errors, and run it and see if our loop is working the way we want it to. So I'll push F5, and we have a menu. Choose one of these desserts. Let's choose ice cream, and the menu appears again, so the loop is continuing. Try all of the menu items, and then when we choose exit, it certainly does exit, and it goes and hits the breakpoint, and that's the pause. We'll just continue from the breakpoint, press any key to continue. So it doesn't do very much interesting so far. It just outputs the menu and continues exit to loop until the user chooses 4, and this stop condition seems to be working correctly. Let's go back to the spec. What else are we supposed to do? Each time they're supposed to print out so far your order is and the amount of the order. So if something happens more than once, it's going to go inside the loop. And let's go back and implement that part. Output the current total price. So what is the current total price? Maybe maybe we'll need a variable for that. So let's declare a double and call it total price and initialize it to 0. This is going to be an accumulator variable, and we will accumulate the sum of all of the items that have been selected so far. So let's put that down here. Printf total so far, a $, percent, 0.2 LF, \n for the carriage return, and total price. So we printed out the total price, but we haven't actually done the accumulation. So let's do that. Total price plus gets, well, which one will we add into the total price? We don't know. If I put ice cream price here, that depends on whether they chose ice cream or apple pie or cheesecake. We have to know which one they've chosen. So I'm going to make a switch, and let's switch on their choice. And we have now some cases. If they chose case 1, if they chose ice cream price, then we want to say total price plus gets ice cream price, and put a break there. In case 2, we want to say total price plus gets apple pie price. And if they chose case 3, total price plus gets the cheesecake price. Now I have an inconsistency in my naming,
So I'm going to go back and change cheesecake to cheesecake price. Total price plus gets cheesecake price. And now we can write total so far is the total price. Well, what if they picked something other than 1, 2, or 3? If they picked something that wasn't on the menu at all, then we might have we might have a default case and print out a message that's not on the menu. So this is an error condition, and remember the semicolon at the end. A break statement in the default case, which doesn't really do anything because the switch would have been over anyway, but it's a good convention to do that. Total price so far is total price. So this is still inside the loop, and let's see if that will compile. So we have a switch statement, that handles each of the cases that they might enter. And there's a bug in it. We don't expect to write code correctly the first time. So if we write 1, the total price so far is $1.50. And then if we choose 2, the total price so far is $3.50. And then if we exit, it says that's not on the menu. Total price so far $3.50. And it hit the breakpoint. Okay, so there's the bug. We have, if they chose to exit, it says that's not on the menu, and that's not the behavior that we want. So we're going to have to add something in here for case 4. And what do we want to do in case 4? Well, so far maybe nothing. So just prevent the default case from happening by having a case 4, which is the exit case. Let's compile that, make sure we haven't put in any typing errors and so on. So we're getting there. We have a do while loop, and each time through the do while loop it outputs the menu and inputs the user's response to the menu. Then a switch statement which will handle each of the possible choices on the menu. If they chose case 1, we'll add in the corresponding price for that menu item, and so on. If they pick something that isn't on the menu, then we'll output this error message that that's not on the menu. And just before we leave the loop, we'll output the total so far is the total price. Okay, go back to the spec. Do we have any problems? Well, there's a $sign here on the menu which isn't in our code, so we can go back and fill that in. We want a $sign on each of these. It's not part of the percent sequence, the format string. It's just before. So we'll put a $sign on the menu just to make it more correct, more like the spec. What else do we have to do before we're finished this? After the user has selected the exit case, we're going to output the total of the order. So, thank you, your order is $3.50. Let's go back and figure out where would we put that. We have two choices. One is we could put it as part of case 4. So when they choose the exit case, we could then do the summary work and allow the loop to be over once the switch is over, but we would be printing total so far as well. So perhaps what would be a better option is to do the summary after the loop is over. And when you look at this and you say, well, how many times does this happen? Thank you, your order is $3.50. It happens only once. That seems to mean it should be not inside of the loop. And we can use that to help us decide that we're going to put the printf, the summary work, out here. Thank you, your order is %.2LF \n total price now. Let's run this in the debugger. So I'm going to put a breakpoint here. First I'll compile, make sure that we didn't put any typing errors in that last printf statement. That seems to be working. And now we'll run to the breakpoint with F5. And we've hit the breakpoint. And if we start stepping through this using the step over, we'll see exactly what's going on line by line. And remember that when you hit the breakpoint, when you hit an input statement, you have to play the part of the user and the debugger at the same time. So we're going to go out here. Let's pick 2 first. So we're picking apple pie off of the menu, and then flip back. Switch on choice. Choice has a 2 in it, and that means that when we go to the next line, we've jumped to case 2, and we're going to add in the apple pie price to the total price. So let's execute that statement. Total price is so far 2.0, and the break statement, when we execute the break statement, we'll see that we are through with the case, the switch altogether, and it goes back down and does the total so far. Execute that. Now, while choice is not equal to 4, is that true or false? While choice is 2, 2 is not equal to 4, that's true. So we're going to go back up to the top and output the menu again. This time we'll pick 1 from the menu. And we're going to switch on 1. We will jump to case 1 and add in the price of the ice cream. So right now we have the total price is 3.5. The break statement takes us out of the switch, and we'll print total so far. 1 is not equal to 4. So we'll go back up to the top, output the menu again, and this time let's choose 7 off of the menu. See what happens in the switch statement when choice is equal to 7. You should be guessing it will drop to the default case and output that's not on the menu, and then it outputs total so far. 7 is not equal to 4, so we'll output the menu again, and this time let's pick 4. Enter. Switch on 4, and case 4 does nothing. Total so far is total price, while choice is not equal to 4, but this time it is equal to 4. Thank you, your order is $3.50. And the program is over. Okay, what I'm hoping that you're getting from this is that the did I start it again by mistake? It's hard to talk and type at the same time. Okay. What I hope you're getting from this is that you don't write code from the top of the page to the bottom of the page and have it correct. You write code and then fix it and rewrite and then fix it again, and it's very much a skill that you develop, and the speed with which you develop it is something that will improve very quickly depending on the problems that you've solved in your past. So we have, let's look at the control structures that we have in this one. We have a do-while loop, which is a repetition construct, and then we have these statements that execute in sequence, one after another, and then we have a switch statement, which is a selection construct, and depending on which of the cases we're dealing with, we'll take some specific action. And you can put as many lines of code in here for each case as you need. The defined constants would allow us to change the program in only one place. Suppose that the price of ice cream went from $1.50 to $1.75. Well, just that one change has changed all of the places where the ice cream price is mentioned. So this now becomes $1.75, and this becomes $1.75. If this program were really long, we wouldn't have to look through all of the instances of that constant 1.75 throughout the program. We can just change it up here at the top, and it makes the maintainability of the code much easier.
Well, it took quite a long time. I hope that you're enjoying it, and we're getting to the part where we start to solve more interesting problems and make programs that do more interesting things. Let's have a look at the only kind of new concept or new language item that was introduced in this segment, and that's the pound define statement. Pound define is for defining a constant that you want to use throughout your file, your code file, and it is not a variable. It's used by the C precompiler to substitute in before the compiling, and it's used to help you make your code more maintainable. So if the price of an ice cream sundae changes, then you only have to go and change that in one place, not throughout the whole code wherever you used it. And the rest of these points here are not so much concepts, but more like advice on how to be coding effectively. And the first one is always have some test cases that demonstrate the expected result for the problem you're solving. It too often happens that I see people writing code and they don't really know what result they want. So it's very difficult to know when you're done if you don't know when the result is correct. That might seem too obvious to state, but I've seen it too many times. Develop the solutions progressively, and that goes with the next ones as well. Compile your code frequently. It doesn't cost very much, only a few seconds to compile the code, and the sooner you find the compiler errors, the more isolated they'll be. If you just typed 50 lines of code without compiling, then you've got an error somewhere in those 50 lines, and if you just type 2 lines of code and compiled, then maybe you have an error in 2 lines, and it's just so much faster. Use the debugger all the time to find what's going on in your code. Sometimes when I'm coding, I will run it step by step in the debugger before I even do anything else, just to see if I'm convinced that the code that I wrote is the code that I meant to write. For loops, for counter control loops, use the shortcut operators that we looked at in the previous segments when you can, when it doesn't make the code more complicated, when it makes it less complicated. And maybe the most important one, and it's not a big intellectual challenge, but if you think about what your variable name should be, then it will make reading your code easier. If you have several variables that count things, don't call them count 1, count 2, and count 3. Use English words. Say it out loud. That often helps. What are you using this variable for? When you say it out loud, that's the name of the variable. Probably 3 words is okay. 4 words is okay. It's one of the big things that cost time in software, and the person that it will cost the time of is you. I hope you're enjoying it, and I'm confident you are, and I'll see you in the next segment.